Hello, madam. Welcome to my channel. So today I am going to discuss here physical pharmaceutics 2 subject of B Pharma 4 semester. Okay. In that unit 1 colloidal dispersions I am going to discuss here in your first lecture. Okay. So first we will see what is colloids. Okay. So the colloidal dispersions are defined as the system in which one phase is dispersed into another phase. Okay, so the dispersed phase where it got dispersed is known as dispersed phase, and where it got dispersed or uniformly distributed, that we can call that as continuous phase or external phase. So the dispersed phase is having the role of internal phase. See, consider here, you see, this is an sugar solutions. Imagine it is an sugar solutions or sodium chloride solution, anything. Okay, so we had taken here the NaCl solutions. Okay, so this are the sodium chloride globules. Okay, or in we can, if it is a sugar solution, it's a sugar molecules. So it is dispersed in your continuous phase is known as dispersed phase, or it is called as internal phase. And where it got dispersed or it where it got uniformly distributed, that we can call as your continuous phase. Okay, continuous phase or external phase. Okay, where it got dispersed we can call it as dispersed phase, and where it got distributed, okay, is called as continuous phase. Okay, so this colloidal particles having the size range between 0.5 to 1 micron. Okay, so in colloidal solutions particles passes through the filter paper, but it should not pass through the semi permeable membrane, and it will diffuse very slowly. Okay, so we have to know why colloidal particles are not passing through semi permeable membrane. Okay, so all the colloidal particles that cannot be passed through a semi permeable membrane in dialysis as well as osmosis, because they are those mixtures in which microscopically dispersed insoluble particles of one of element are suspended in another element. Okay, it's like suspension. We can give suspension as an example. You know what is suspension, right? So the insoluble drugs are distributing, right? So the dispersed phase is known as distributed. Dispersed phase is known as dispersed phase, and where it got distributed is known as continuous phase. Okay, and we can see what are the applications of colloids in pharmacy. One is it has a surfactant miscellaneous, then we say suspensions, emulsions, and inhalation of aerosols, and suspension of microorganisms. Okay, and we will go through the classification of colloidal systems. Okay, the classification of colloidal system according to the particle size there are three types. Okay, so according to the particle size it is divided into three types. One is molecular dispersion, and another is colloidal dispersion and coarse dispersion. Okay, so we will see it in a detail. Before that, we will see what is an applications of colloids. We'll see what is an applications of colloids. Okay, first in the treatment of in therapy. Okay, so the colloidal system are used as a therapeutic agents in different areas. Okay, so we can give silver colloid as a germicidal, and copper colloid in the treatment of cancer, and mercury colloid at an anti-syphilis. Okay, And next, coming to the stability part, lyophobic colloids. Okay, lyophobic colloids prevent the flocculation in suspensions. Okay, for example, next you see colloidal dispersions of gelatin is used in coating over tablets and granules, which upon drying leaves a uniform dry film over them, and it protect them from adverse conditions of the atmosphere. Okay, and the third application is absorption. As colloidal dimensions are small enough, the particle size is small of in the case of colloids. Okay, so they have a huge surface area. Okay, if the particle size is small, it is having the more surface area. Hence, the drug constituted colloidal foam is released in a large amount. Okay, so the absorption will be faster if in the case of colloids. And next is on targeted drug delivery. In the case of targeted drug delivery, we can give as a liposomes as an example. Liposomes of colloidal dimensions and are preferentially taken up by the liver and spleen related issues. Okay, and coming to the classification of dispersed systems. Okay, so the dispersed system consists of a particular matter. One is dispersed phase and distributed throughout a continuous phase. The continuous phase we can call it as external phase or dispersion medium. Okay, where it got distributed, and they are classified according to the particle diameter of the dispersed material. So this is classified according to the particle diameter of the dispersed material. First one, molecular dispersions. Okay, molecular dispersions is a lesser than 1 nanometer. So they less than 1 nanometer sized particles are coming under the molecular dispersions. Okay, so these particles are invisible in electron microscope. Okay, and it pass through semi-permeable membrane and filter paper, and it won't settle down on standing, and it will undergo a rapid diffusion. Examples are ordinary ions and glucose. Okay, and next we will coming to the next part, colloidal dispersion. So colloidal dispersions is our topic now. So the colloidal dispersions, 1 nanometer to 0.5 micrometer we can consider, and the particles not resolved by ordinary microscope, and it can be detected by using the electron microscope. Okay, and pass through the filter paper, but do not pass through the semi permeable membrane. You know the reason why it is. And particle made to settle by centrifugation. So in this case, particles we are settle by using the centrifugation method. So we will see what is centrifugation. Is a method of separating the molecules having different densities by spinning them. Okay, by spinning them in a solution around an axis. Okay, at high speed rpm we are using. So in simply we can tell centrifugation is a process that uses centrifugal force for the separation of two liquids in a mixture. We can call it as centrifugation process, and it will diffuse very slowly. And example is colloidal silver solutions, and natural and synthetic polymers are the example. And we will see in detail about the colloidal dispersions. The colloidal dispersions are defined as the polyphasic system. Okay, where at least one dimension of the dispersed phase measures between nanometer, and one will be in the range of micrometer. The term, okay, the term colloid implies the glue like structure in glue like substance in the term Greeks. Okay, So colloidal system is a dispersion where a dispersed particles, also known as internal, and the dispersion distributed, where it got distributed we can call it as dispersion medium or external phase. Okay, and colloidal system is a state of matter, okay, has dispersed phase intermediate in size between small molecules or ions in solutions and large particles as in suspension. So you can see the figure from the CVS Subramanian, okay, textbook. First one is the homogeneous phase. Okay, that's known as truth solution, which is having the size range less than 0.01 micrometer. We can give example as urea, sucrose, oxygen, gas, and ions. Okay, when we will do the condensation, it will get to the heterogeneous phase or colloidal dispersion, which upon dissolution will come back to the original state. Is a reversible process. Okay, so the heterogeneous phase is known as colloidal dispersions, and the size range is 0.5 to 1.0 micrometer. So the examples are acacia, albumin, insulin, and silver salts. Okay, and the next, the homogeneous phase upon the flocculation or aggregation, it will form a heterogeneous phase or coarse dispersion, which is having the size range of 10 to 1000 micrometer. So the example is calamine suspension and magnesium oxide and RPC. Okay, so this coarse dispersion is also having a dispersion medium and a dispersed phase. Okay, and the heterogeneous phase on mechanical dispersion, it will form an heterogeneous phase of the colloidal dispersions. Okay, this is about your in the state of matter discussion, and we will see the differentiation between the molecular dispersion versus the colloidal dispersions. Okay, so in the first column they gave the property, and the second column molecular dispersion, and the third colloidal dispersions. Okay, so if we consider the size of the particles, in the case of molecular dispersion, it will be less than 1.0 nanometer, and in the colloidal it will be 0.5 micrometer to 1.0 nanometer. That means have to always remember it is a range starting from the micrometer to the nanometer. And the visibility became not visible even with an electron microscope, the molecular dispersions, but the colloidal dispersions visible with the ultra microscope and electron microscope. Okay, then in the scattering of the light, molecular dispersion does not scatter, and the colloidal dispersion it will get scatters and shows a Tyndall effect. And next is transport across semi permeable membrane. Molecular dispersions will cross the membrane, and the semi and colloidal dispersions are impermeable. Okay, and next is settling. In the case of settling, the molecular dispersion does not settle on an ultracentrifugation, but our colloidal dispersion will settle on ultracentrifugation, and the diffusion rate of molecular dispersion is rapid comparing to the colloidal dispersion, because the colloidal dispersion is showing the slow diffusion rate. Okay, so the classification part is over, and we will see next characteristics of the dispersed phase. Okay, so first we will see first particle size. So the particle size which is influences the color of a dispersion media or dispersions. So wavelength of light which absorbed by a particles will be approximately related to its radius, and the larger the particles, the shorter the wavelength of the transmitted. That is, the color approaches the violet of the spectrum. See, for example, colloidal gold, which is having a red color in the range of 650 to 750 nanometer, intermediate in violet color. Okay, in the case of the coarse dispersion of gold, which appears blue, okay, blue color, which will show on 450 to 490 nanometer. And next we will see the Next characteristic, that is particle shape. The shape of particles in a dispersion, which depends on methods of preparation and affinity of the particles to the dispersion medium. And the shape also influences the color of the dispersion. So it is believed that spherical particles of gold is indicated by red in color, and disc like are gold gives the blue color, and the shape of dispersed phase influences also the viscosity of the dispersion medium. And the spherical particles produce dispersions of low viscosity, and the linear will produce more viscous dispersions. These effects are reflected by a degree of solvation, and the good solvent or vehicle produce particles with a maximum surface. Poor solvent makes the particles to coil up to assume spherical shape. Accordingly, all associated particles are affected. Okay, and next we will see what is surface area. Surface area, in the case of surface area, particle size small or large surface area. Effective catalyst also required to enhance the solubility. The larger surface area which enhance the solubility of the drug particles in presence of any suitable or effective catalyst. Okay, so example of catalyst we are using here, it is platinum colloids. Okay, and the last, surface charge. Surface charge on nature of dispersion medium and ions present in colloidal solutions. Colloidal particles acquire a charge on their surfaces. Colloidal particle possess charge on their surfaces. Surface charge provides valuable information regarding the stability of colloids. So the charge is very much important in the case of colloids, in the case of stability. Okay, particles move continuously in random manner with collisions with each other. The like charges on the particles create repulsion forces. And positive example, gelatin and aluminum, and negative acacia and tragacanth. So particle interior will be neutral, and the surface will be charged. Surface charge lead to the stability of colloids because of the repulsions. The phenomenon of repulsions is helping to colloids to achieve their stability. Okay, so I hope all you understood. So we discussed here in this class introduction to colloids and its classification and its characteristics. Okay, so we will see in the next lecture too. So if you have any doubts, please comment below the channel, and as soon as possible I will reply. And if any clarification or if you want anything more, I will try to put next video also in detail. So thank you so much for watching.